Hi guys, let's look at the next question. The next question that we do is question number 29. It says 1 plus sin A upon cos A plus cos A upon 1 plus sin A. Okay, and on the right hand side we have 2 sec A. So again the left hand side looks more complicated than the right hand side. So let's start working with the left hand side. Again I notice I don't have any square terms on the left hand side, which means I should try and convert this into somehow square, which means let me first take the LCM and add. So this will be cos A times 1 plus sin A, that will be the LCM, and the numerator will become 1 plus sin A whole square plus cos square A. Right? I'll multiply, cross multiply basically because there is no common term. But that's how I get the LCM. Next, let's look at what does this give us. Let's open the brackets. So when I open the brackets, I get 1 plus sin square A plus 2 sin A plus cos square A upon cos A into 1 plus sin A. Let's see if this helps. What I have is sin square A plus cos square A, which will give me 1 more, right? Because sin square A plus cos square A is 1. So this gives me 2 plus 2 sin A, 1 from here, and sin square A plus cos square A is 1 upon cos A times 1 plus sin A. Since cos square A plus sin square A is equal to 1. That's my reason. Anything common in the numerator? Yes, I notice both the terms have 2 common. So 2 times 1 plus sin A divided by cos A times 1 plus sin A. Now I notice 1 plus sin A is common on both numerator and denominator. So dividing both sides, both numerator and denominator by 1 plus sin A, it gets cancelled. So what I am left with is 2 upon cos A, which is nothing but 2 sec A, since 1 upon cos A is equal to sec A. That's my reason. So this is equal to my right hand side. So hence proved. Done. Let's look at the next question. The next question that we do is question number 31. It says cot A minus cosec A whole square is equal to 1 minus cos A upon 1 plus cos A. So let's work with the left hand side. I notice on the right hand side I have cos, and on the left hand side I have cot and cosec. So let me just convert both of them into sine and cos, and let's see if this helps us. So cot would become cos A upon sine A, and cosec A would become 1 upon sine A. This is whole square. I started working with the left hand side. The reason being, since cot A is equal to cos A upon sin A and cosec A is equal to 1 upon sin A. That's the reason. Next, let's see if I can add and see what will this help me get. So if I add this, this becomes the S sin A is the denominator, is the LCM, and numerator becomes cos A minus 1 whole square. Let's open this. So this becomes cos square A plus 1 minus 2 cos A upon sin square A. I notice that the numerator can also be written as 1 square plus cos A square minus 2 times 1 times cos A. Basically nothing. I'm just writing this again as in the form x minus y whole square. But this time I'm interchanging x and y. So earlier I was writing this as cos A minus 1 whole square. Now the same thing can also be written as 1 minus cos A whole square. Why? Because when I square the difference of 2 terms, the value is irrespective of the sign, because both the so let me give you an example. 3 minus 2 whole square will be 1 square, which is 1, and 2 minus 3 whole square will be negative 1 square, which will still be 1. which means it doesn't matter which one I use first. X minus y whole square is equal to y minus x whole square. That's what is basically I'm trying to do. And the denominator is sine square a. Now this can be written as 1 minus cos a whole square, and the denominator can be written as 1 minus cos square a. Why? Because reason being, since sine square a is equal to 1 minus cos square a. What this gives me is, this is 1 minus cos a whole square, and the denominator is in the form x square minus y square, which means x plus y multiplied with x minus y. So 1 minus cos a and 1 power of 1 minus cos a gets cancelled, and I am left with 1 minus cos a upon 1 plus cos a, which is my right hand side. So hence proved. Interesting question, where we first converted cot and cosec into sine and cos, then we added, then we squared, and then we interchanged x minus y as y minus x. Good. Let's look at the next question. The next question that we do would be question number 33. So question number 33 says tan square a minus tan square b. I need to prove that this is equal to sine square minus sine square and cos square cos square. So I realize that my right hand side is only sine and cos. So let me just convert the left hand side also into sine and cos. So I am working with my left hand side. The left hand side becomes sine square a upon cos square a minus sine square b upon cos square b. Perfect. The reason is since sine x is equal to, since tan x, sorry, my mistake, we've converted tan into something. Since tan theta is equal to sine theta upon cos theta. Perfect. So now let me take the LCM. I notice that I've already got the denominator of the right hand side. So the LCM will be cos square a into cos square b, which I've already got. So at least one part of my work is done. The LCM of these two terms would be cos square a multiplied with cos square b, and my numerator will become sine square a times cos square b minus sine square b times cos square a. So when I subtract these two terms, this is what I get. Now my job is to ensure what is there on the right hand side. So on the right hand side, I notice that there is no cos square b, and I notice there is no cos square a in the numerator. Let's go and check again. I realize that I've got my denominator already. So let's look at where do I need to reach in the numerator. In the numerator, I don't have any cos square. So let me just remove this cos square. And do I have any relationship between cos square 1 or sine square? The only relationship is cos square is equal to 1 minus sine square. So let me just replace cos square b with 1 minus sine square b. Perfect. So let me just replace and see what does it get me. So let's start writing. This gives me sine square a times 1 minus sine square b, and the second term becomes minus sine square b times, instead of cos square a, I write 1 minus sine square a. Perfect. The denominator remains the same, cos square a times cos square b. A reason, since cos square theta is equal to 1 minus sine square theta. Done. Let's open the bracket and see if it helps us. So sine square a minus sine square a into sine square b minus sine square b plus sine square a multiplied with sine square b, and the denominator is cos square a times cos square b. Anything gets cancelled in the numerator? Yes, I have a negative sine square A sine square B, and I have a positive sine square A sine square B. So this gets cancelled, and what I am left with in the numerator is sine square A minus sine square B upon cos square A into cos square B. That's exactly what they wanted. This is my right hand side, so hence done. Let's look at the next question. The next question that I do is question number 35. So let's look at how we can solve question 35. We can either start with the right hand side, which looks slightly more complicated, or we can work with the left hand side and rationalize. Because I know if I rationalize in the denominator, I'll get 1 minus cos square. But let's try the right hand side method. So let's work with right hand side this time. So my right hand side is cosec A, and I notice that on the left hand side I have only sine and cos. So I'll convert cosec into 1 upon sine A. 1 upon sine A minus cot A is basically cos A upon sine A. The reason being, since cosec A is equal to 1 upon sine A and cot A is equal to cos A upon sine A. Done. So these are the two reasons. Next, I notice that I'll have to add them up, or in fact in this case subtract them. I take the LCM, which is sine A. This becomes 1 minus cos A upon sine A. I have to move ahead from this. So what should I do? Maybe I can. I have to convert this into 1 plus cos, and the relationship between cos and sine is sine square plus cos square, which means in the denominator I should have sine square. If I have sine square here, I should be able to get 1 minus cos square. Let's try. So let's multiply both numerator and denominator by sine A. Why am I doing it? Because I need to have a denominator of sine square. So what I get is sine A times 1 minus cos A upon sine square A. Next, I know that sine square A can be written as 1 minus cos square A. So this is sine A times 1 minus cos A upon sine square can be written as 1 minus cos square A. The reason being, since sine square theta is equal to 1 minus cos squared theta. Perfect. So let's just move on and see what can we get from here. So what I get here is the denominator is in the form a square minus b square, which can be written as a plus b into a minus b. So my numerator right now is sine A times 1 minus cos A, and the denominator becomes 1 minus cos A times 1 plus cos A. In the form x plus y into x minus y will give me x squared minus y squared. 1 minus cos A and 1 minus cos A gets cancelled. So I am left with sine A upon 1 plus cos A. This is basically my left hand side, which is what they wanted me to prove. So hence proved. Done. Is there another way of doing it? I could have done this with the rationalizing the left hand side, and I would have got the similar answer, but that's fine. Let's look at the next question, or should I try and solve this question, same question with the left hand side? So let's try. We'll solve question number 35 using the left hand side method as well. So let's look at this. So question 35 for us was sine A upon 1 plus cos A. I have to prove this is equal to cosec A minus cot A. Perfect. So let's rationalize the left hand side. So rationalize left hand side, and what I get is sine A times 1 minus cos A upon 1 plus cos A times 1 minus cos A. This gives me sine A times 1 minus cos A and this is basically nothing but x plus y into x minus y, which is x square minus y square. Now this basically turns out to be sin a times 1 minus cos a upon 1 minus cos square a is nothing but sin square a. Reason being, since 1 minus cos square a is equal to sin square a. Done. Let's look at the next step. Once I've got this, I can cut one sin a and the second power of sin a. So what I have is 1 minus cos a upon sin a. Let's divide, or let's separate these terms. So this would be 1 upon sin a minus cos a upon sin a. 1 upon sin a is nothing but cosec a, and cos a upon sin a is nothing but cot a. Now we'll write the reason. Since 1 upon sin a is equal to cosec a and cos a upon sin a is equal to cot a. Perfect. So this is nothing but my right hand side. So hence proved. I hope you realize you can start with whichever side in any of the questions. You will eventually get to the right hand side or the left hand side, depending upon what is more comfortable for you. So that finishes this video for me. Before I move on, let me give you some homework questions. So homework questions for you this time would be question number 34, 32, 30, 28 and 26. Thank you so much. Take care. Be safe. Bye bye.